Hey everybody. Today we're talking about percentiles of continuous random variables. The pth percentile of such a random variable is the value pi sub p such that there's a p% chance that x is less than or equal to pi sub p. So it's a value in the support of the random variable. I think a picture's helpful, so here I've shown it for a normal distribution. We have the value pi sub p, and the area to the left of that should be exactly p%. Now technically, a percentile is always an integer between 0 and 100, though they're sometimes written as decimals between 0 and 1. The context almost always makes it clear which one's intended. This is a place where mathematicians and statisticians are sometimes a little sloppy, and it's mostly okay. Mathematically, the pth percentile is defined in terms of the CDF, the cumulative distribution function big F of x. And so it can also be written by writing an integral of the probability density function. So here's the math. We're saying that p% of the area lies to the left of pi sub p. So that means big F of pi sub p is p%. Same thing with the integral from negative infinity to pi sub p, f of x dx. I think an example helps to solidify all of this. So let's work through one in some depth. Compute the 10th percentile of a random variable x with this PDF, 1 minus 1/2 x, and the support is from 0 to 2. So to find the 10th percentile, we need to find the value pi sub 10 such that the area to the left of that value is 10%. In other words, we need to integrate from negative infinity to pi sub 10, which will mean integrating from 0 to pi sub 10 here, integrate that PDF, 1 minus 1/2 x. When we do that, we should get 10%. So here's the math. We end up getting a quadratic out at the end, and that quadratic ends up having two solutions. But only one of them is in the support of the random variable. So this random variable only has non-zero probabilities between 0 and 2. So we ignore the 3.90 solution. The 10th percentile here must be 0.103. Here's a picture for that. We have the probability density function on its support. And of course, the total shaded area under the entire probability density function is 1. So what we're saying here is that the darkly shaded area is exactly 10% of this total area. The area to the left of that 10th percentile, 0.103. The quartiles of a continuous random variable are the 25th, 50th, and 75th percentiles respectively, so Q1, Q2, and Q3. Similarly, the deciles are the 10th, 20th, 30th, and so on percentiles. So that's just a little vocabulary that you'll run into occasionally when you're studying continuous random variables. The last example, that random variable, has deciles 0.103, 0.211, 0.327, etc. And I've drawn them all here. So all of the shaded regions here should have equal areas because the area to the left of the first decile is 10%, the area to the left of the second decile is 20%, and so on. So even though these regions have different widths, they all have the same areas. They divide this support up into 10 regions of equal total probability. The median of a continuous random variable is the 50th percentile. And so we compute the median in exactly the same way as any other percentile, doing an integral over from the beginning of the support to the value m, integrating the PDF, setting that equal to 50%. In this case, we get 0.586. Notice that that's not the same as the expected value, which for this example is 2/3. Nor is the median the same as the maximum of the probability density function, that is to say, the mode of the distribution. All three of those things measure different things.